Good morning. You're at Gruber Motor Company, and these are Tesla Roadsters. The history of the Roadster is an interesting one. The original founders of Tesla decided that they wanted to make an electric sports car, and they didn't have the ability to actually build car bodies, so they went to Lotus in the UK and they said, look, can you guys sell us a bunch of shells, gliders they call them, and we'll electrify them. They picked the Lotus Elise and went on contract to purchase 2,400 of these cars, and then electrified the drivetrains to make a pure battery electric vehicle called the Tesla Roadster. So as a pure battery electric vehicle, the Tesla Roadster needed to have a pretty sizable battery. It was patterned actually after an obscure car called a T0 made by AC Propulsion Systems in San Dimas, California. They only built 3 of them using lead acid batteries, or wet cells basically. And the idea that the original founders of Tesla had was, why not use laptop batteries? By laptop batteries they meant lithium-ion cells, 18650 cells, and they crammed 6,831 of them into a 1,000-pound battery pack and then jammed it up inside this Lotus Elise and called it a Tesla Roadster. What the battery looks like on the inside is like this. This is our high voltage battery repair section, and these are sheets out of a Tesla Roadster. There are 11 of these sheets in each car. The combined total weight is about 1,000 pounds. Again, 6,831 lithium-ion cells. They look like this, like your common vape cigarette cell. And when it goes up inside the car, it's pretty remarkable because somehow they crammed that 1,000-pound monstrosity up inside that little Lotus Elise. This particular car is having sheets replaced, and it's been dead for 2 years. When we're done, this is going to again be a driving car. This car is a salvage car that has some body damage, and you can see the passenger or the driver fender here is a bit crumpled. Fortunately, this car has a good propulsion battery pack, or ESS pack. So this particular customer sent us 2 cars. This is a clean titled car here, and what we're doing here is the same thing. We drop the battery pack on this Roadster and we're going to do a sheet swap. And the reason we can't just simply swap the battery packs or the ESS packs is because these are 2 different versions of Roadster. This is a 1.5 Roadster and this is a 2.0 Roadster, and the packs are different. So what we are doing is transplanting sheets out of one enclosure into another enclosure to get this car fully operational again. One of the first things that we had to do was a recovery on this battery pack, because sitting at auction houses they generally kill these Roadster battery packs by not charging them. And sure enough, this one came in dead, but we were able to do a level 1 recovery and get it back functioning. Turns out that the sheets in this are in excellent condition. So before we do a transplant, what we end up doing is using a custom piece of machinery that we built here. And this is a charging system that actually will charge all 11 sheets to precisely the same voltage. They are using DC to DC converters that are current limiting, and we're able to dial in the voltage we want, usually the highest voltage in the pack, and set the current limit and get all of the voltages in the sheets to exactly the same level. The reason for doing that is once it goes into the car that we're trying to make operational, we will get maximum range, and essentially that pack will already be balanced by the time that we do the transplant. We talked about this being an auction car and being bricked at the auction, and this car is also bricked, but the difference between the two is this car was bricked for 2 years and this car was bricked only during its auction experience, which was about 3 to 4 months. So this was a much easier battery recovery than this one would have been. which after 2 years, there probably aren't any good sheets left in that pack, which is pretty much what we confirmed once we opened up the pack and found that all of the sheets were at 4 volts or below. A normal sheet voltage is usually around 36 to 37 volts if it's a functioning pack, which is what we're seeing in this pack here.